my dear warriors, welcome. How was your board exam? How was your bio exam? Those of you are probably enrolled into PCMB. Good evening, everyone. Let me know in the chat box and how many of you are waiting for the last exam to be over in the next couple of days. So I hope that you are utilizing this gap which is there before your last and final exam of your boards for preparing for JEE. And I hope if you have missed the classes which were conducted before, you are watching it. Also, if you need help, you are taking the help of the playlist which is there on the channel. Make sure you watch as many videos to develop your understanding, to practice more problems, to see more mock tests, or to learn something or revise something. Everything is there on the channel, your favorite JEE English channel. And let me tell you guys, today's session is all about the 11th standard syllabus JEE crash course for all JEE 2023 and JEE 2024 aspirants. And we are going to do center of mass, collisions, rotational motion with revision, with PYQs, with problem solving, and of course your daily practice problems with me, Shreyas, your physics master teacher. Nice to see all of you out here, and I hope you guys have smashed the like button already. And if you are not, do that right now, and make sure you are on the channel by hitting the subscribe button. I'm very good, Haris. Hello Kailash, hello Blessy, hello Krishna. Nice to see all of you. Hello Tanga, Star Sailor, Bhuvesh, Control Clicks. Wow, what names. Why is horizontal circular motion FBD we don't consider F is equal to mg? Because you know the angles are so less, you're rotating it with so high speed that it's okay to neglect that mg. Okay, that tension is much higher than mg, so you're rotating it so fast it becomes a conical pendulum where theta is basically close to 90 degrees. I'm very good. My throat is much better, and I'm pretty sure you will be able to also say the same thing by hearing my voice right now. What is convex lens? Please watch my ray optics classes, right? Okay, it's there. Okay, I think it's a very simple question. You should please watch the basic understanding questions or basic understanding concepts from the Pathfinder series. So let's begin with the class, and let's start with the revision starting from center of mass. Center of mass is nothing but a point where all the mass can be assumed to be concentrated, where all the mass can be assumed to be concentrated, and the formula for that in general, RCM, be it x coordinate, be it y coordinate, or be it z coordinate, is nothing but m1 r1 plus m2 r2 plus mn rn divided by m1 plus m2 plus mn. If you want, you can put a bar symbol. If you don't want, it's okay. You can put x, y, z coordinates also. I'm much better, Blessy. Thank you. Much better, Shabana. Hello, Prasad. Yes, capture classes for VIT Triple E. Definitely, bacha. It's coming up immediately after your first attempt. Okay, don't worry. Now, if you want to use this formula, you need to keep in mind this is okay if the masses are discrete. That means you can separate out the particles. You have m1 mass here, m2 mass here, so on and so forth, mn mass over here. This is basically discrete masses. But if you have a continuous body, you take dm mass, so this is basically a continuous body like a solid sphere or a cone or things like that. In that case, the RCM formula is integral RDM divided by the total mass. RDM divided by the total mass. Many times you might have to find the mass via some linear integration, areal integration, or volume integration. That is very rare. Generally they ask such kind of questions in JEE Advanced, not in mains. But remember, generally they give you mass per unit length, which is basically dm by dx, or they give you mass per unit area, that is basically sigma, so that is dm by dA, or they give you mass per unit volume, that is rho, which is your normal density. From this you can integrate to find the total mass. You can integrate to find the total mass of that body. That is what it is. Okay, I hope this is clear. Now, having said this, you should know the standard center of mass of different bodies. Example, starting off, let's see how many of you remember all of these guys. First of all, if you have a hollow hemisphere versus a solid hemisphere. So let's start with hollow over here, and then we talk about solid hemisphere. This is a hemisphere, half of the sphere, hemisphere. So where do you think the center of mass lies? Where do you think the center of mass lies? Okay. Akarsh, Young's modulus and all that low weightage topics, no, I'm not going to go over it. You can watch my previous classes. SHM, I'm not going to teach, I'm going to revise, okay? And classes for 2024, first let's cover up the revision, then we'll talk about it. Step by step, bacha, okay? Concentrate on the class. Yeah, is it R by 2 for this guy or this guy? For solid, it is lower. Hollow, it is, I think, R by 2. And for solid, it is little bit lower. It is 3R by 8. Very good, guys. Similarly, the next thing is for a cone. For a cone, if you talk about a cone, everybody should remember these formulas. Again, if it's a hollow cone, it is h by 3. Okay, it is h by 3. If it is solid, it is basically h by 4. Solid has more mass below, so it is lower. That's why it is h by 4 from the base. Exactly. Okay. Another important thing which you should know is for an arc and a solid sector. Example is this. Imagine you just have an arc over here. Just an arc. It's just an arc. It's hollow. Versus a solid sector. This is like a pizza. This is like somebody ate the pizza and left the crust for you. Just the crust for you. Happens, no? How many of you just eat the pizza and sometimes you're like, sir, I don't like the crust. I give it to my brother or sister or my friend. The friend, no, he likes that kurum things are like just like that masala dosa you get. No, it's very nice, crispy, sir, it is. Yeah, so something like that. So this is basically your solid sector. This is like your solid sector. This is your arc. If the arc subtends certain angle, then the distance of the center of mass is given by r times sine theta by 2 divided by theta by 2. Same formula here, r sine theta by 2 by theta by 2, but there is a factor 2 by 3 which comes. So that is the distance of the center of mass. That is the distance of the center of mass from the center of the circle. That's what it is. Yep, very good. Now theta is the total angle. Please remember that. Theta is the total angle. If you take half angle, then you just put sine theta by theta. If you take half angle, then put sine theta by theta. Theta is obviously in radians. Another important thing is that you can use this formula for finding center of mass of semicircular disc or quarter of a circle and so on and so forth. Just put the value of theta. This is a more general formula, Godfather formula, rather than by hearting individual formulas. Now what happens when particles start to move? Then if the particles move, their center of mass also moves. That brings you to motion of center of mass. So we are talking about now motion of center of mass, guys. So simple formula, velocity of the center of mass is given by m1 v1 plus m2 v2 and mn vn. Same type, similar formula upon m1 plus m2 plus mn. Standard result. Isn't that right? Very good, guys. Very good. And similarly, acceleration of center of mass is m1 a1. You know the individual accelerations, individual masses, and whatever, this is mn an, right? The whole thing divided by m1 plus m2 plus mn. That's how it works. Apart from that, you also have momentum of the center of mass. Momentum of the center of mass is not m1 p1 plus m2 p2 upon m1 plus m2. That's what many people mistake it to be. But that's not correct. I have been, conducting interviews, and when I ask teachers also, what is the formula for momentum of center of mass? They're like m1 p1 plus m2 p2. No, that's not true, guys. It is in fact it is just p1 plus p2 plus p3, like that. So p1 plus p2 plus p3 plus p4. So till the last particle. So it's basically the total momentum of the system is also the momentum of the center of mass. Very standard, important result. No problem, Harshini, I just started. Maybe you missed 5 minutes, you can replay that part which you have missed. Okay, great. Similarly, there is also Newton's law which is associated for moving particles. When there are number of particles, number of forces, internal, external, their center of mass also moves, especially in the problems where a boat, man is there, man is moving this way, boat moves how much? Monkey is climbing a rope on a balloon, the monkey goes up so much, the balloon comes down by how much? A firecracker blows into pieces, then the center of mass continues its journey as if there is no other new force, only gravity is there. The particles might just disperse at different places. So all these things are completely based on the principle of Newton's modified law for multiple particles or system of particles, which just says that the net external force, the net external, not internal, only external, okay, is equal to the total mass. The total mass into what, guys? Acceleration of the center of the mass of the system. So if you have many particles, this is my system, my dear students, of mass m. Multiple external forces are there. Multiple external forces are there. You take the net force, net external force, that will be equal to mass, total mass, into whose acceleration? Center of mass's acceleration. The center of mass will have some acceleration. That is what it is going to be. If it was one particle, then it is one force is one mass into acceleration of that mass. If it is another mass, that force on that mass into that particular mass into that guy's acceleration. So when it is total mass, you take the total force and the acceleration of the entire thing assumed at the point which is the center of mass. So acceleration of that point. Exactly. Understood? Everybody with me? Clear? Oh? Understood? Oh? Can we move ahead? Where problems involve center of mass doesn't move, then you can use this special condition, which is 0 is equal to m1 displacement of particle 1 plus m2 into displacement of particle 2 and so on and so forth. So m into displacement plus m into that guy's displacement plus m into another guy's displacement, their sum will be always 0. That is the simple trick which you can use to solve problems where center of mass is not moving. Like I told you before, person moves on the plank or on the boat moves behind, the person goes this way. Those problems involve this equation. Is that okay? Fair enough, guys? Okay, I hope you guys are revising everything. And by the way, those of you who do not know this, I have already shared the short notes of this entire thing beforehand only. And I'll be sharing the short notes of SHM and waves and the remaining chapters as well by today evening. So guys, if you don't want to make that effort because hardly 3-4 weeks are there and you want all the short notes printed form ready made for you in a crisp way so that you can quickly go through the theory, formulas, concepts, that's it. Use the link which is there in the Telegram channel. So when you go into the Telegram channel, there will be a link. Use that link, download those PDFs, go through it again and again and revise. Okay, fine. Moving on. Already I have done high weightage topics, Rakesh, but for the second attempt, definitely I will make a separate video for it. Don't worry, Rakesh. Okay, moving ahead now to momentum, impulse, collisions and stuff like that. So starting off with momentum. Momentum, we all know, is a vector quantity, is nothing but P is equal to mass into velocity. Also, kinetic energy is the momentum square by 2m. Now, when the momentum changes, that's when you call it as the impulse. Impulse is basically the change of momentum. Change of momentum. So symbol for that generally J or I, it's a vector quantity. It is delta P, which is basically final minus initial momentum. That is one way. Or you can write it as force into the time for which it acts. Force into the time for which it acts. That is also okay. That is only if F is basically constant. But if it is not constant, don't worry. Integrate force with respect to time from T1 to T2. Basically, the area under force versus time graph also gives you impulse. All these are basically different ways of expressing impulse. Okay, I hope this is clear. Now, apart from this, you will see many questions which involve conservation of momentum. or collisions happening or explosions happening. So what do you do when there are collisions, explosions, or a person jumps from something, or a person jumps onto something, something is moving, you add onto it. So basically conserve momentum. Basically problems which involve conservation of momentum. What you need to do, first important step, this is very important, or else you will make some or the other silly mistake, my dear students. Always show diagrams. One is before diagram and one is after diagram. There might be different particles moving in different ways, whatever. They might be spreading, they might be exploding, they might be splitting, they might be merging, whatever happens. And then the next step, what you're going to do is the total momentum initially will be the total momentum finally, and this is vector. If you want, it will be separate in x, in y, in x, in y. If you want to solve it in 2 dimension, if it is head-on collision, 1 dimension collision, only one equation will be there. But if 2 particles come like this and they go like that, then you have to write 1 equation in x, 1 equation in y. Makes sense, right? PYT JEE almost same syllabus, almost. Definitely, Hari Tripathi, this is for 11th as well as 12th students. Okay, bacha log, everybody with me? Understood? But remember, even when momentum is conserved, important thing is energy may or may not be conserved. Very, very important. Energy may or may not be conserved. Great. Now there are 3 cases for that. 3 cases for that. I'm pretty sure you would have heard about it. First one is basically elastic collision. In elastic collision, the coefficient of restitution is 1 and the final kinetic energy is equal to the initial kinetic energy. No loss of energy, the best type of collision. But then you have the other type of collision, which is basically inelastic collision, which is more realistic collision, where the final kinetic energy is less than the initial kinetic energy. The value of E, which is coefficient of restitution, is less than 1. The third worst type of collision, is perfectly inelastic type of collision. In this kind of collision, you will notice that E value is 0 and the final kinetic energy is less than the initial kinetic energy, and the body is basically moved together. They move together. That's what is happening in this kind of collision. They stick to each other and they move together. What is this coefficient of restitution, somebody might ask? This coefficient of restitution is the relative speed of separation upon the relative speed of approach. That's what you need to keep in mind. If you try to remember the formula V2 minus V1 upon U2 minus U1 with the negative sign, or U1 minus U2, what was it, sir? Who was U1? What is the direction? 100% that is going to cause a lot of silly mistakes. Instead, remember relative concept. Everybody knows how to find relative speed. Chapter number 2, chapter number 3 or whatever, you know, your 11th standard. So there you have learned how to find the relative speed. Now see, before, okay, what is the relative speed? Okay, after, what is the relative speed? Just find it out and divide. Always separation afterwards will come on the top numerator. Whatever happened before, okay, before the collision, while approaching, that will come below, downstairs in the denominator. Is that okay, bacha? Okay, very good, very good. Yes, thank you, Akash, for letting others know. Hello, Khushi, nice to see you after a long time. Thank you, Sai Verma. Thank you, man. All right, very good, Haris. All right, moving on to the next few things. In elastic collision, there are some very specific properties which you should be aware of. Very specific properties, like elastic collision. In case of elastic collision, there are very specific properties, like if you have a mass and another equal mass, then if they collide, then what happens is their velocities get exchanged. Meaning, if this mass had u velocity, after the collision, this mass will get u velocity. If this mass had, let's say, v velocity, this mass will get v velocity. That is one of the property. Two equal masses colliding elastically, their velocities get interchanged. Okay, velocities get interchanged. So keep this in mind. Another important property is where you have a teeny mini mass colliding with a very heavy mass. Then what happens is after the collision, let's have a look. Okay, if this mass is moving with speed u, then after the collision, what happens is that same mass, okay, just returns back as it is with the same speed. Okay, the other mass remains at rest. Nothing happens to it. It remains at rest. So this is another important property which you should be aware of. Another important property is a very big mass colliding with a very small mass. Very big mass colliding with a very small mass. Then what happens? Let's have a look. So imagine this guy was at rest, but this guy was moving with certain speed. After collision, the big guy's velocity will not change because it is very big. Hardly any effect will be there on the big guy. But the small guy will move with twice the speed as compared to the previous mass. Okay, I hope this is clear. Yep, yes. I look tired. Oh, yeah. No problems, guys. I mean, obviously, I would be tired because I have been just taking rest from yesterday because of the medication. That's all. So, but it's okay. Don't worry about my tiredness or anything. Just concentrate on the session. Okay, because you know I'm here to work only for you guys. Okay, so your exams are very close by, or else I could have just put leave for next 2-3 days and said that okay, I'm feeling very tired. My voice is still not recovered. I'm on medication, so let's just chill out. But no, I can't do that. Okay, your exams are there. Let's go ahead now. Okay, let's go ahead. What's the next step? After this is basically directly we go on to slowly rotational motion, because these are the main things that you need to remember in collisions. In rotation, you start off with some basic concepts like moment of inertia. And moment of inertia is nothing but summation of mass and r. Each mass from the axis, how far it is, that is r. So mass into distance square, mass into distance square is the moment of inertia, right? So what happens if 1 kg mass collides with a stationary mass of 5 kg elastically? Akash, 1 kg and 5 kg are not that far apart. I mean 1 kg is close enough to 5 kg. If it was 1 kg and 500 kg, then you can use this, or else do not use. Then you have to write equations. m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. Second equation, E is equal to relative speed of separation, relative speed of approach. E will be given. Okay, it is 1. Solve it simultaneously and get the answer. Okay, fair enough. Okay, now you should know the moment of inertia of standard objects. Let's have a look at it. Moment of inertia of a ring. Let's see, what is it? Come on guys, moment of inertia of a ring is also similar to moment of inertia of hollow cylinder. Same things, and that is basically mr square. Moment of inertia of a disk is same as moment of inertia of a solid cylinder, which is nothing but mr square by 2. Moment of inertia of a hollow sphere is nothing but 2 by 3 mr square. Moment of inertia of a solid sphere is nothing but 2 by 5 mr square. Moment of inertia of a rod is ml square divided by 12. Right? These are the main important formulas you can say for moment of inertia, and the two important theorems or properties which help you shift the axis, find the moment of inertia about new axis, and all of that are the parallel and perpendicular axis theorem. So if you have a body and you know the moment of inertia about center of mass, let's say it is ICM. Now you take another axis which is parallel to it, separated by a distance of d. So you add mass of the body into d square, you get the moment of inertia about the parallel axis. So you shift the axis parallelly from the center of mass, that is the parallel axis theorem. Another theorem that you have is perpendicular axis theorem. If you have a flat object like this book over here, okay, and you know the moment of inertia about this axis, this axis and this axis, both are perpendicular. Yeah, L is the length of the rod, Harshini, definitely, yes, L is the total length of the rod. This axis and this axis, then the moment of inertia about this axis when the book rotates like this will be given by I, or whatever, that perpendicular will be I1 plus I2. You can say that I1 and I2 are the moment of inertia of the body when both the axes are in the plane of the body and perpendicular to each other. That's how it is. Okay, so this is called perpendicular axis. A lot of people behave it as Iz is Ix plus Iy. No, don't behave it as Iz is Ix plus Iy. What is that X? What is that Y? Understand, I1, I2 are the two axes which are in the plane of the body. So if this is the body, okay, it says I love my dog. I hope you guys also love your dogs if you have one, or whatever animals you have. Somebody has a crocodile, somebody has a monkey, or somebody is a monkey, I don't know. So guys, yeah, so what is I1 and I2? If you have an axis in the plane, that is I1, you take another axis, that is I2, and the third axis will be perpendicular to both of them. That is this I perpendicular to the plane of the body. It is only valid for planar objects. This has no condition. This is valid for everything. This is valid only for planar objects only, laminar objects only. Lamina means plane. Keep this in mind. Okay, bacha log? So these are important things regarding to moment of inertia. Now from moment of inertia, you slowly go on to dynamics, like torque. Torque, tau, is basically the cross product of the distance where the force acts into the force. Magnitude wise, torque is nothing but R into F into sine theta, where theta is the angle between R and F. If this is the axis, R is the distance where the force acts, this is the distance where the force acts, this is theta, then I will get the torque like this by doing cross product. That is how torque looks like. R is here, force is here, you do R cross F, I'll get the direction of the torque. Now this torque is also related to the moment of inertia by this formula. The torque acting on a body, the total torque acting on a body is moment of inertia into alpha. This is just like force is mass into acceleration. Alpha is angular acceleration. This is moment of inertia or rotational inertia. This is equivalent of force in rotation. So very similar to Newton's law, but just that it is in rotation. Yep, I hope this is clear. No, Kushi, I will not be taking any JEE batch this year. No, none of the batches will be taken by me. Okay, right, great. But you will have my AI live classes, the recorded classes available for all of you in case you want that. That's what it's going to be. The reason why I will not be taking classes because I'm completely involved in all these other activities, so I won't be able to do justice. If I take a batch, I need to devote a lot of time over there. Don't worry, you have excellent teachers who will be taking care of you. Okay, don't worry. Next important thing is that whenever you see that the net torque is 0 and net force is 0, then that becomes the condition for rotational and translational equilibrium. There are many problems involving toppling, or two ropes supporting a rod, or a person being supported by two things, or maybe there is a fulcrum and two things are there and it is being supported or balanced. All those problems involve concept of force being 0, net force being 0, and the net torque being 0. All the torques cancel, all the forces cancel each other. So you will see many problems which involve both these equations as well. Now this torque is also related to another quantity called as angular momentum. Just like you have momentum, you have angular momentum. So angular momentum. So there are two formulas for angular momentum. If, for example, you have just a point mass, not a big body, point mass, then the angular momentum is given by mr cross v. This is for a point mass. But if you have a rotating body, then it is moment of inertia into omega. Lokesh, the next session will be tomorrow morning 10:30. Siva, KTG and thermal physics class was supposed to be yesterday, but I hope you know that I was not well, so that's why I had to cancel it. Instead, I gave you the problem solving session, or rather the sheet, daily practice problems. Whichever problems I was going to do, I made it into a sheet, but I gave you the solutions. It's uploaded on the Telegram channel. Why I cannot do it again? Because we don't have time. Okay, so that's the reason. I know it. I also feel bad for canceling it, but that's the best thing I can do. And tomorrow I'll be taking SHM and waves. That is also important. And day after tomorrow I have to take mock tests. And after that we are going to go towards more mock tests, revision strategies, more problem solvings, and so many other things. So that's the reason, Bacha, we are really short on time. That's the reason why I didn't want you to at least miss on the problem. So I gave you all the problems. I gave you all the solutions. Whatever I was going to do, plus the daily practice problems, everything is there. Okay, just have a look at it. Now, like I was saying, this torque is also related to angular momentum. If I might remember, in Newton's law, force was the rate of change of momentum. So here, torque is the rate of change of angular momentum. So I am just going to say that torque is just like force was the rate of change of momentum. Here, instead of force, it's torque. Torque is rate of change of angular momentum. That's all. As simple as that. Very, very important. And you can also have more formulas which are very similar in translational mechanics or linear motion. Like, for example, kinetic energy. Kinetic energy, instead of half mv square, it will be half I omega square. This is rotational kinetic energy. Rotational work, I can just say, instead of force into displacement, I can say torque into angular displacement. All these formulas which were then valid are also valid here, but just that the symbols and their terms are slightly going to change, but they are going to look very, very identical. Rotational power, just like power was force into velocity, here it will be torque into angular velocity. All these formulas are very, very similar and identical. Okay, so keep this in mind. This is rotational kinetic energy. Mind it, if a body is translating as well as rotating, it will have both kinds of kinetic energy, rotational as well as translational. You also will see many problems involving conservation of angular momentum, conservation of L. Basically, L is basically constant. This happens if the net torque acting is zero. If there is a body on which outside torque is not there, or they are there but they are cancelling out each other, net torque is zero, then the angular momentum initial is angular momentum final. This is the main thing of it, the main thing, formula of the statement, I would say. And many times you will see I1 omega 1 will be equal to I2 omega 2, or if there are two discs merged together, I1 omega 1 plus I2 omega 2 will be I1 plus I2 into omega final. These kind of questions are based on conservation of angular momentum. A rod is there, a bullet strikes it, hits it, sticks to it, and both go together. Angular momentum of the bullet plus the rod is the final angular momentum of the system. A disc was rotating, suddenly the radius changed. So the new inertia will be different. So the new speed will also be different. All these questions based on conservation of angular momentum. But remember one thing, energy or momentum may or may not be conserved. May or may not be conserved. So these are two different things. If momentum is conserved, does not mean energy is conserved. If energy is conserved, does not mean momentum is conserved. If angular momentum is conserved, does not mean linear momentum is conserved. Three different things. So don't mix all of them. Everyone has their own unique characteristics, own criterias, different criterias. So you should know who has what criteria. For angular momentum, it is torque should be zero. For linear momentum, force should be zero. For energy to be conserved, no non-conservative forces should do work. Each one has different criteria. Is that clear? Oh, what is this? Hearts and 100 and smileys? Oh my God, is this some kind of a new feature? Or what? On the chat box. I've never seen this. Yes, Siva, adding some object. Yes. Very good, Krishna. You already practiced some problems. Very good, Kushi. I hope many of you are 11th standard students also, I guess. How many of you are 11th standard students? How many of you are 12th standard students? JEE 2023, JEE 2024. I would love to know that. Just put it up in the comments if you are watching it recorded. If you're watching it live, then let me know in the live chat box. Okay. Then you also have the concept of rolling, slipping and all of that. Remember, whenever you have a body which rolls, then V is equal to omega R. This is only when it is in the case of rolling, but if it slips, then V is not more than, V is not equal to omega R. Okay? Just keep this in mind. This is the concept, and this will have both rotational and translational kinetic energy. Also, in such a rolling body, this has V speed, this has 2V speed, this is at rest, this has root 2V speed, this point has root 2V speed, and so on and so forth. So different points have different speeds, something which you should be knowing about. Okay, 2023, some of you are even droppers, very nice. Another important thing which you should be also aware of, if you take a rolling body and you leave it down an incline, then it will have certain acceleration. That acceleration is given by g sine theta upon 1 plus the factor which comes in the formula of moment of inertia. A lot of people do not remember it this way. They try to bahut it in complicated manners like I by mr square or k square by r square and all of that. I do not like that so much. I like the word factor a lot, because think about it. For example, for ring, what is the factor of moment of inertia? It is mr square. It is 1 into mr square. So the factor is basically 1. For disk, it is half mr square. So the factor is half. For solid sphere, what is the factor? It is basically 2 by 5. So on and so forth. It becomes very easy to remember it like that. Makes sense, right? Yep. That's how it works. So I feel it is much easier to remember it in the form of factor formula rather than going it by some other way. So these are the main things which are there in rotational motion. I think we should solve some problems now coming up on your screen, and here it is. Are you guys all excited for the problems? Let me know in the chat box, guys. Okay, get ready for the first question coming up on your screen. Lots of problems with PYQs, and towards the end you're going to get a DPP which will be uploaded on the Telegram channel. Link is there in the description box below. Moving on. If a ball of mass 0.2 kg moving with a speed of 2 collides elastically with another ball 0.4 which is at rest, find the velocities after collision. Like I've been telling you, always show the diagram before and after, visualize the situation and then go ahead. So this is 0.2 kg moving with a speed of 2 meters per second. Okay, it hits another mass elastically with 0.4 kg. This is at rest. After the collision, this 0.2 will have some speed v1, this 0.4 will have a speed v2. Because it is elastic collision is 1, so relative velocity of separation upon approach is 1. Separation will be v2 will be faster, obviously, because after it hits the next mass will go faster. So v2 minus v1 is the speed of separation. Both are going like this, so the relative speed will be bigger speed minus smaller speed. Approach speed will be just 2, so v2 minus v1 is basically 2. One equation. Second equation, conserve momentum. So conserve momentum. So initial momentum 0.2 into 2 plus 0 is equal to 0.2 into v1 plus 0.4 into v2. So point cancels, 2 2s are 4 plus, or I can just put is equal to, because it's just 0. Point cancels everywhere. So 2v1 plus 4v2 divided by 2. So 2 is equal to v1 plus 2v2. So I got two equations. I think I can solve them simultaneously. Take this equation, just add them both. Just add both of them. What do you think will happen? See, the moment you add both of them, see guys, v1 and v1 cancel. 2v2 plus v2. 2v2 plus v2. v1 cancel. 2 plus 2 will be there on the other side. 2 plus 2. So this will become 3v2 is equal to 4. v2 is equal to 4 by 3. That is one answer. But we want one more answer, guys, and that is v1, let's say. So here v2 I can put as 4 by 3 minus v1 is equal to 2. So v1 will be 4 by 3 minus 2, which is basically minus 3 2 is 6 minus 2 by 3. So V1 will be minus 2 by 3. See where is the answer. Minus 2 by 3 and 4 by 3. Option A, right? Option A. Instead of Vi, can we write V2 minus 2 instead of Vi? This is not Vi, this is V1. Acha, so you're saying instead of V1, can I write it as V2 minus 2? Yes, Bacha, Krishna. Definitely. Hello, Roshan. I know you guys are interested in the NEET crash course as well. Let me see, Bacha. Let me work it out. I'm planning things. Okay, for now, Roshan, you can watch this also. It will help you for your NEET. It's not like this problem cannot come in NEET. Obviously, it can come in NEET. Okay, level of JEE Mains and NEET is almost similar. Moving on, next question. In two separate collisions, coefficient of restitution is E1 and E2. And the ratio is 2:1. Interesting. So, E1 by E2 is 2 by 1 as per the given information. In the first collision, velocity of approach is twice the relative velocity of separation. So, if I take velocity of separation and velocity of approach in the first collision, that is E1, as per the condition, approach is twice that of separation. So basically this is twice of the numerator. So 1 by 2 is basically E1. So question is, for the second collision, what is the situation? Okay, from this, substitute E1 is equal to half here. E1 is equal to half here. Rest of the things is as it is. So E2 will be 1 by 2 into 2. So it is basically 1 by 4. So E2 is nothing but velocity of separation upon velocity of approach in the next collision, in the second collision. But the question says find the ratio of relative velocity of approach upon separation. So this is separation upon approach. That means approach upon separation will be 4:1. That should be the answer. So a lot of students will make mistake and they will write it as option A. That's why I'm doing this question. If you find this, it's not that this is wrong, but this is not what is asked. The asked question is approach by separation. So always read and give what is asked. Very common mistake which many students do. There is a ball which hits another ball, and that itself comes to rest. Half the energy gets destroyed. The coefficient of restitution is. Let's visualize this and then solve further. Mass M1, speed U1. Mass M2 at rest. The first mass comes to rest. The second mass moves with some speed V2. As per the given condition, conserving momentum, what do I get? M1 U1 is equal to M2 V2. Because this guy is at rest, so M1 U1 is equal to M2 V2. So you can also say M2 by M1 is also equal to U1 by V2. That is one thing. Another thing, half the energy gets destroyed. So that means final energy is basically half of initial energy. So final energy is half M2 V2 square, half M1 U1 square. Half gets cancelled. I will just bring M1 here. So M2 by M1, okay, into V2 square. I can bring it on the other side. Okay, I can just take it on the other side. So only half will remain. So U1 square by V2 square. But wait a minute, M2 by M1 is U1 by V2. Is nothing but U1 by V2. So just put U1 by V2 over here. U1 by V2 over here. Rest of the things are as it is. So half into U1 square by V2 square. U1, V2 gets cancelled. So I'm just getting U1 by V2. U1 by V2 is basically 2 by 1. That's what I got. Take that 2 on the other side and cancel the rest. Now see what the question is. Question is, what is the coefficient of restitution? E is speed of separation, which is V2, upon speed of approach, which is basically U1. So V2 by U1 will be 1 by 2. So hence the value of E is half. Hence the value of E is basically half. See if it makes sense. First thing was drawing diagram. Second thing was conserving momentum, just to figure out what is the ratio of the mass. Nowhere in the question they said masses are equal. Next thing, I use the information, half the energy is lost, so half the energy will be remaining. So that's all. Solved it, everything made sense after you substituted values and things started getting cancelling out. And because coefficient was asked, it is speed of separation upon speed of approach. Got it, guys? Okay. Anushri, don't worry, bacha, of your physics board exam. I think you are in Maharashtra board or something, because I don't know which exam, which state has exam tomorrow. I think in Andhra it is there next to next week or something. Yep. Thank you, Daily Shorts. Very good, Kushi. Great. Moving on to the next one. If a ball falls from a height of 5 meters, coefficient of restitution 0.4, height after 2 collisions is approximately. There is standard question. If you might have solved, if you have attended my nurture series, also you would remember this. If you drop a ball from height h, right? If it hits the flooring with speed u, after the first collision, the speed will become e times u, the height will become little bit less, and it comes back down with the same speed, the reduced speed. This height is e square times of h. Again it hits, now it rebounds with even lesser speed and goes up till a lesser height. This speed will be e square times u. Every time the speed gets multiplied e times, the height gets multiplied e square times. This will be e raised to 4h. This is your first collision. This is your second collision. So after first collision it goes till this height. After second collision it goes till this height. You might ask, sir, why is it e square times the previous height? Because height is speed square by 2g. If you take a ball and throw it up, what's the maximum height formula? Speed square, u square by 2g, right? So hence that's why it is the case. I hope this is clear. Oh, tomorrow is a board exam for ISC. Oh, I didn't know that. All the best, bacha log, especially ISC students. So I think now it becomes easy. So the height after the second collision will be e raised to 4 into h. So e is basically 0.4 raised to 4 into height. Just check this out. How much does it come out to be? Just check this out. See if it comes out to be 0.128. Obviously it can't be 30 meters. 30 is out of question, guys. I mean, this also not possible. This also not. How can it go higher, na? It was like obvious. It has to be 0.128. By elimination also you can solve it. If you drop a ball, how can it go higher? Unless something magical is there in it. So it doesn't make sense. Anyways, option B was correct. Moving on to the next one coming up on your screen. Alright, Anushri, Kerala board. Okay, interesting. Now I know why some students are like, sir, I have that exam, sir, I have this exam. I know, very tough time for all of you. And plus you have to balance these boards as well as JEE Main second attempt is there. I hope you guys do really well in your boards, and please do not forget studying for JEE Mains, because at the end of the day, you're going to get a good college only via JEE Mains and not through boards. Boards is just for qualification. That's all. Keep this in mind. Moving on to another question. A particle. Okay. So there is a particle of mass m moving with speed 3v. Collides with another mass 2m moving with speed v. Same direction. There is a perfect inelastic collision. The loss of the kinetic energy of the system is. Okay, let's draw the diagrams. Without that, no point. Particle of mass m moving with speed 3v collides with particle of mass 2m moving with speed v. After the collision, it's a perfectly inelastic collision, so the mass will become 3m. They will have a new speed v1. Okay, use conservation of momentum. So m into 3v plus 2m into v will be 3m into v1. So this will become 3 plus 2, which is 5mv is 3mv1. So v1 will be 5v by 3. Okay, I found v1. But the question is, what is the loss of kinetic energy? So loss of the kinetic energy, because initial energy will be more. So initial energy minus the final energy. What is the initial energy? It is half mass 3v square plus this guy's energy, half 2m into v square. That is initial minus final. Final is basically half 3m into V1 square. V1 is 5V by 3. So 5V by 3 square. Now, this is very easy to solve. This is very easy to solve. I'm pretty sure you can solve it, okay, within few steps. MV square, MV square, MV square is common. In fact, you can, oops, why did I put 3? This should be half, my bad. This is half, guys, yeah. So MV square by 2 will be common, and so many other things will be there, like 3 will be there, and then you will have 2 over here, and then you will have minus over here, and this will become 25, and this 3 and this 3 will cancel, 1 3 will remain, so 25. So this will become 25. Oops, 20, wait a minute, I need to erase this. Yeah, so this will become just, you know, like 3 plus 2 minus 25 by 3. So something like that. And just check what is the final answer you get. Yep. 9. What is 9? This 5e square by 9. But this 3 and this 9 will cancel. Only 1 3 will remain. Yeah. So I think you should get the answer as 4 by 3. Just check it out. Just check it out. Yep. Awesome. 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 Great. Great. After kv square. Oh, acha, understood what you guys are saying. Acha, over here, this bracket was missing. My bad. Thank you so much. Smart students. Everything else is fine. So 3v square. So that means over here also this should be 9, I believe. Just check it out. This should be 9. Now do the math and see if you get this as 4 by 3 mv square. Yep. 4 by 3 mv square. Is there a separate channel for chemistry, physics and maths? Blue Willow, bacha, you already have a separate channel. This is a separate channel only, no? For physics, chemistry, maths together. But if you want chemistry separate, maths separate, physics separate, no. Unfortunately, that is not there. Or fortunately, whatever. I don't think it is needed. Okay? Yes, Siva, it is option A. Will there be a class for maths concepts, Akarsh? No, bacha. I'll be taking only the mock test right now, okay? Because I really can't devote so much of energy for maths concepts also. So I'll be taking care of your maths in the form of mock tests. But if you want maths concepts, there's a crash course which is going on. Separate teacher is there in English. The teacher is teaching you the maths concepts also, revising the concepts. So you can join the crash course if you want to. Okay. Kushi, you did not get the answer. Just check it out once more. Okay. Just see. This was 9. This was not 3. 9 plus 2 and this is 25 by 3. Okay, just check that out. See now if you get it. Now if you get it. Okay, I think you should get it. See after doing the calculations, you should get this as 4 by 3. Yeah, just try it out once more. Okay. Solid sphere is moving, makes an elastic collision with another stationary sphere, 1/3 of its radius. After collision, it comes to rest. Ratio of the densities are. Interesting question. A solid sphere moving, okay, let's say mass is m1, moving with certain speed, let's say u, collides with another mass, okay, 1/3 the radius, okay, and that is at rest. After the collision, what happens is this mass m1 comes to rest and the other mass m2 begins to move. We have seen what happens in elastic collision. If velocities are getting exchanged, the masses are equal, and that's what happens in elastic collisions. Remember, that was the property of elastic collision, that the velocities get exchanged. If this was at rest, now this guy is at rest, this was at rest, now this one is at rest. So that means whatever this speed is there, this guy's speed, if you are asking what it is, it will be nothing but the same speed u. And also mass 1 will be equal to mass 2. That was the property of elastic collision. Harish, I wish I could have done that, but then what happens is the session will go on for a very long time, number 1. Number 2, when students watch it as recorded, there is an awkward long pause. Even in the live class, what you can do, if you feel like, okay, I want to take some time, you can always pause the video, you can continue. It will be like a live session only, don't worry, okay, if you want to do that. But I will be giving you problems for homework in the form of DPP. Yeah, that's the thing. Now, here is the thing, guys. The question says, what is the ratio of the densities? Masses are equal. Is mass related to density? Yes, it is. How? Mass is density into volume. So mass 1 is density 1 into volume 1. This is density 2 into volume 2. So basically density of the spheres are rho 1 by rho 2 will be nothing but V2 by V1. Volume is 4 by 3 pi, 4 by 3 pi, 4 by 3 pi, and you have r cube and r cube over here. So r2 cube and r1 cube. 4 by 3 pi gets cancelled. R2 by r1 remains. The radius of the other sphere is basically one third of the previous one. So R2 is 1/3. So this will be 1/3 whole cube. So that is 1 by 27. 1 by 27. So the question says what is the ratio of the density of the second and the first sphere? So rho 2 by rho 1. So rho 2 by rho 1 will be 27 divided by 1. That should be the answer. Just check it out. Yes, it is. So not 1:27, it is 27:1. Perfecto, Siva. Is that okay, bacha? Everybody understood? The property of elastic collisions has been used here. That's why I got speeds get interchanged, and that's why the masses should be equal. Masses are density into volume. Rest is just simple ratios. Moving on to the next question coming up on your screen. A particle is going horizontally with certain speed u, sticks with a particle of equal mass hanging at rest at the end of a light string of length L. The string rotates by 60 degrees and then stops. What is the initial speed? Let's understand the situation. There is a light string of length L. The mass is m. Another mass is moving with certain speed u. Also, after the collision, what will happen? It will now become a 2m mass but with a new speed v. After some time, what will happen is that this thing will go up and stop over here. This goes up by 60 degrees and stops. So in this entire process, what has happened is inelastic collision is happening, and in this inelastic collision some energy is getting lost. So you will see the final speed will be slightly less also, and once they become a combined mass and they have a new speed, that kinetic energy goes or is utilized in raising the mass up by some height. So how much height does this go up by? That's very simple to find. This height is basically this total length minus the length cos 60, minus length cos 60. So that will be L minus L by 2, which is basically L by 2. So this mass has gone up by L by 2 height. That means the potential energy has gone up at the cost of the kinetic energy. So I can definitely say over here that half into the mass into the v square is equal to m or rather 2m, because 2m is there, into g into L by 2. 2m cancels, so v, in fact this 2 and this 2 also cancels, so v square will be gl. V square is gl. That's not the end of the story. Or even if you find v is root gl, that is not the answer. The question is find the initial speed. Question is not find this speed, question is find this speed. How do you do that? Conserve momentum. Conserve momentum. Here the momentum was mu, okay, plus 0. Final momentum was 2m into v. So basically u is equal to 2v, right? So u is equal to 2 into root of gl. Hence that is the answer. That is the answer. 2 into root gl, yep, option B. So you should always see what is asked. The question was not to find v, question was to find here. Here to here, energy is not conserved, momentum is conserved, because it is in elastic collision. From here to here, momentum is not conserved, energy is conserved. That's what I was saying some time back. Everything has its own unique characteristics and criteria. Every part of the problem might involve different concepts. Here to here, it was momentum. Here to going up, it was energy conservation. Okay? Beautiful question, understood. Can we move ahead to the next one? What is this? Both the bodies move towards each other, collide inelastically. The velocity of the first body before is 3, second is 5, common speed is 1 in the direction of the first body. How many times did the kinetic energy exceed that of the second body before the collision? Okay, interesting question. So let's have a look. Two bodies are moving towards each other. Their masses are definitely not given, so I'll just call it m1. This is basically 5. Sorry, first body before the impact is 3, and the second body second, oh sorry, why am I putting 2m? It's just m2 that is moving with speed of 5 towards each other. So this is basically 5. After the collision, it is found that both of them move together the common velocity, so it will become now m1 plus m2 in this direction with the speed of 1, in the direction of the motion of the first body. That is what is given. So conserve momentum. What will you get? 3 into m1 minus 5 into m2 is equal to m1 plus m2 into 1. So 3m1, bring that m1 over here, shift this guy over there, so 5m2 plus m2. So this will become 2m1 is 6m2. So therefore m1 is 3 times of mass 2. That is the relationship between the mass. That is the relationship between the mass. I hope this is clear. Now, sir, what is the 2 mgl by 2? Mass gh, that's all. In this case, this was mass into g into height. Height was L by 2. That's why that 2 has come. Is that okay? How much height did it go up? Not complete L, only half of that height. I hope that is clear. Great. Moving on now. Where are we? Question says, what is the ratio of the kinetic energy with respect to the other one? So kinetic energy, how many times did the kinetic energy of first body exceed that of the second body before the collision? So basically what you have to find is kinetic energy of the first body minus kinetic energy of the second body. Oh, sorry, not minus, upon. Because it is asking how many times. So k1 by k2. Now it's very simple. It is half m1, 3 square upon half m2. Basically, what is it? You can see over here, 5 square. So m1 by m2, you know, m1 by m2 is basically 3. So into 3 square by 25. So 27 by 25. I think it is going to be 1.08. Just check it out. Good evening, Likith. Hello, Neeraj. Hello, Harshini. Yes, got it. Very nice, guys. If you guys have got this as 1.08, perfecto. Okay, it's just asking how many times is the kinetic energy of the first body with respect to the second body. Just divide, half gets cancelled. m1 by m2, you can get it from here only. See this. m1 by m2 is basically 3 by 1. So that 3 by 1 I have put it over here. 3 square is 3, 9, 9 3s are 27, 5 square is 25. So 27 by 25 is slightly more than 1. So 1.08, yes, that's the answer. Next question coming up on your screen. What do we have? 2 position vectors, masses also given. What is the position of the center of mass? I mean, this is by far one of the easiest question. Position vector of the center of mass. It is nothing but m1 r1 plus m2 r2. Okay, everything bar upon m1 plus m2. That's it. So what is m1? m1 is basically 200. Okay, upon 200 plus 100. What do we have over here? First vector I plus 2j plus 10k plus 100 into this guy. So minus I plus excuse me, plus 2j plus 3k. Okay. Now 0, 0, 0 you can cancel everywhere. This 0, this 0, this 0, this 0. You can just cancel it out. So things will be much easier. So denominator will just become a big fat 3. This will become 2i minus I. So I. 4j plus 2j. So plus 6j. 2 into 10, 20 plus 3. So 23k. That's it. That's the answer, guys. So see where it is. I plus 6j plus 23, that's option C, of course. Very good. Harshini, Telegram channel you can never use for asking doubts because it's a channel. It's only one-way communication. When you have to ask doubts, you can do one thing. You can probably, if you're in the part of the crash course, you can use the doubt app. Number 1 option. Number 2 option, you can leave a comment after the session ends. Okay, that is another option. Third option, I would have said that okay fine, you can ask me on Instagram, but that is not possible because I have many messages over there, so becomes very difficult to reply to every one of you every time. So best is either use the doubt app or just leave a comment. Hopefully somebody will answer, or even I will try to answer. Moving on. 2 rods, 5 meter, 2 meter, end to end. Linear density is given. The position of the center of mass from the interface is what? Let's try to do this. Okay. So first rod, 5 meters length. Second rod, only 2 meters length. Okay. Densities are 4 and 1. This is 4 kg per meter. This is 1 kg per meter. So the mass will be 4 into 5, that's 20 kgs. 1 into 2, that is 2 kg. Correct? If you look at the center of mass of any one or both of them, center of mass will be here and here for both these individual rods. Center of mass 1, center of mass 2. Now the question is, where is their combined center of mass? That's the question. So for that, best thing to do is take this axis as the origin. Take this interface as the origin, and this is your x-axis, this is y-axis, this is your origin. Now you can find the coordinate very easily. How? Observe. The x coordinate of the center of mass will be m1. m1 is basically 2 into x1. From this point to this point, how much is this distance? You only think and tell me. The rod is of 2 meters. Center of mass will be exactly midway, no? So this will be how much? 1. Everybody understands this? Why it is 1? So m1 x1, that's the first term, plus m2. m2 is 20. x2, what is x2? See, this was 5 meters. So this is 2.5, but on the left side, negative side. So minus 2.5. The whole thing divided by total mass. So 20 plus 2. Just check this out. 20 into 2.5 minus 50. So basically 2 minus 50 upon 22, which is minus 48 divided by 22, which is minus 24 divided by 11. I can see 24 by 11. 24 by 11 meters on the side of the heavier rod. Yes, this is the heavier rod, that is the lighter rod. So magnitude wise, it is 24 by 11 from the interface on the heavier side. So I think it is option A. It is option A. Yes, it is. Hello Harinath Tiwari, good evening bacha. Thank you Blue Willow. Abhishek, I'm so happy for you bacha. Boards over finally. Now full on focus on JEE Mains and JEE Advanced. Can you take 5 meter as origin? Krishna, yes you can take. But why will you not take? Because the question says of the center of mass from their interface. Already they have mentioned the origin. So that means the origin has to be taken as the interface. That's the understanding of it. Else you'll have to again shift and adjust the distances. I don't want you to do that. It's a waste of time. Next question coming up on your screen. What does it say? Bent rods. Question is, where is the center of mass? Simple, easy peasy. Now, a lot of students are going to find x and y coordinates and then do the problem, but I am going to do it in a much easier and simpler fashion. The center of mass of this rod will be here. Center of mass of this rod will be here. Yes or no? The rod's length is 2 meter. So that means this is 1 meter. This is also 1 meter. But from here to here, only this much is 0.5 meter. And only from here to here is also 0.5 meter. Yes or no? So forget the rods and just look at it as point masses. One point mass here at a distance of 0.5 meter and another point mass over here, same mass, at a distance of 0.5 meter. Just imagine this. Just two masses. Forget the rod because the rod can be assumed like a point here, point here. Now you need to find the total center of mass. That means you need to find the center of mass of these 2 point masses. Understood the logic? So first get rid of the rod here and here, treat them like points. Now find the center of mass of these 2 point masses. So it will be on the line joining these 2 masses. Obviously the masses are equal, so the center of mass will be on the exact midpoint. So you can just drop a perpendicular bisector. That's it over there. It's a perpendicular bisector. Everyone with me? So guys, now you know what should be this particular distance D. how much should this distance be? It's very simple. This whole angle was 120. So each of this angle will be 60 degrees and 60 degrees. Yes or no? So what will the value of D be? Oops, what just happened? What will be the value of D be? Think about it. D will be equal to 0.5. This is a right angle triangle. 0.5 cos of 60 degrees. So 0.5 into half, which is basically 0.25 meters. That's the answer. Yep, there you go. That's the answer. Thanga Santosh, let me tell you, the rod's length is 2 meters and it is bent. 2 meters was the length of this rod. This was 2 meters. And now you bend it at the center. So this will be 1, this will be 1. Center of mass will be half of that one. So 0.5, 0.5. So a lot of halves are there. I think you missed that. Okay. 75% criteria generally is there for PCM category. Plus, I think the compulsory subjects might be there, either electronics or whatever computer science you are taken. I think they include that as well. Okay, I need to check the proper, you should read between the lines. You should see what they have exactly given. Yep. NCERT plus Vedantu Enthuse YouTube channel, enough for JEE Mains. Definitely Harupiya, Shenukul, this is a complete end-to-end channel. I try to do things where you don't have to go anywhere else also. And I'm planning to give you more material in the days to come. Yeah, is the second attempt going to be tougher, Viswa? Yes, I feel that the second attempt will be tougher than the first attempt. Okay, first attempt usually I think they'll keep it easy because you would not be so well prepared. Second attempt, maybe you might find it difficult for one more reason. Even if you get same marks, preparation level will be higher for all the students. So for the same marks, the percentiles will increase because boards are over. You would have studied for boards. Half the portion is done. Plus students would have understood the mistakes. Many students join crash courses. They give mock tests and so many things. So their natural tendency is the performance increases. So it's a good chance. It will be tougher maybe from not just the actual question point of view, but also from the competition point of view. Next question coming up on your screen. Thank you so much, Koshi. Yes. Viswa depends, bacha. I cannot say whether 150 is good or 200 is good. Depends what you want. Do you want this branch, you want that branch, you want this NIT, or you just want to qualify for JEE Advanced? So it all depends on what is your aim and ambition, right? So it depends. Now in this kind of question where you have a mass and you take out a cavity out of it, and the question is where is the center of mass, the usual formula for such things is XCOM is mass of the entire sphere into center of mass of the sphere, complete sphere, minus mass of the cavity into center of mass of the cavity upon mass of the sphere minus mass of the cavity which is taken out. That's the idea. Now, if you try to solve this, let's see what happens. See, this entire sphere has a mass m. So for the sphere, the mass is m, radius is r. For the cavity, the radius is r by 2. Obviously, look at this, the radius will be r by 2. Does that make sense? It is r by 2 radius. So how much will be the mass? Some students will be like, sir, half the mass. That's not correct, bacha. Think that the mass is actually proportional to volume, and volume is proportional to the cube of the radius. 4 by 3 pi r cube, volume of the sphere. So if the radius doubles, mass becomes 2 cube or 8 times. If the radius becomes half times, half raised to 3 is 1/8 times. So this will become m by 8. Does that make sense to all of you? Why it becomes m by 8? Great. Hari's same level, as in like it will be of the same mains level. That's all. But don't expect it to be suddenly of advanced level or some crazy questions. They will be plus or minus some 5%, 10% level in difficulty. That's all. But competition is going to be tougher, and I feel you should prepare for a 5 to 10% or 15% tougher side paper, just in case if NTA decides to change their mind, or they feel that, oh, students will be well prepared or whatever. That's all for the preparation standpoint. I hope the paper comes out to be easy and everybody scores well. That's always going to be your hope. But when you prepare, you have to prepare for the worst, right? Yes, competition will be tough, definitely. Great. So if this is clear, just substitute. What is the mass of the sphere? M. Coordinate of the center of mass of the big sphere, it is at the center. So origin. So origin is 0. That's it. So remember, I'm taking this as the x-axis, this as the y-axis. This is my origin. Okay? Best to take that only as the origin. So into 0 minus mass of the cavity, m by 8. X cavity. The cavity center of mass is here, which is the radius, basically r by 2. The whole thing divided by m minus m by 8. Now it's simple. This is 0. So this will become minus m r by 16 divided by 7m by 8. So this will become mm cancels. So minus r by 7. So I think this 2 will also be there. So into 2. So minus r by 14. So radius is 4. So 4 by 14, which is minus 2 by 7. So minus 2 by 7 or 2 by 7 magnitude wise, that is there. So what is the distance? That's all they have asked. So when they ask distance, it is basically the magnitude. It is the magnitude, right? So that's all. So option is B. Yes, it is option B. Understood? Oh, clear? Oh, amazing. Oh, can we move ahead? Oh, to the next question, guys. Ready? Coming up on your screen, and here it is. A metal rod of length 2 meters suspended from a rigid support at 0, heated, coefficient given. What is the shift of the center of mass? Read the question again, then you will understand. Meanwhile, I'll just draw the diagram. Okay, so this is a rod. Center of mass will shift because the rod will expand, obviously. Where will the center of mass be? If the rod's length is L, it will be at exactly half the length. What is the length of the rod? It is clearly mentioned that it is 2 meters. So actually it will be at 1 meter. Now in order to find how much does the center of mass move by, use the formula delta L is L naught and 1 plus alpha, sorry, not delta L, because we have delta L, there is no need of 1. So L naught into alpha delta T. What is L naught? L naught is 1. What is alpha? 18 into 10 to the power minus 6. What is delta T? It is 100 minus 0. That's it. So this will be 18 into 10 to the power minus 4. That's it. That is delta L. That is the answer. As easy as that. Many students do not think and they write L naught as 2 meters. No, that will be the total change in the length of the rod, not the shift of the position of the center of mass. Center of mass is midway, so everything will get divided by 2. So instead of 2, put 1. Then you will get the correct answer. Got it? Simple, easy peasy. Moving on to the next question. Coming up on your screen. 2 masses given. What is the magnitude of the acceleration of the center of mass? Acha. First of all, these kind of questions, masses are equal. Kya? Okay. This is also M, this is also M. So there will be a force from this side, which will be mg sine 60. And there will be a force from this side, which will be mg sine 30. So obviously this will be higher force. So acceleration will be here as well as here. Both will have same acceleration. Easy to find the value of acceleration, guys. So acceleration will be bigger force minus, that is mg sine 60, minus smaller force, which is mg sine of 30. Whole thing divided by total mass, which is m plus m. So this will become g common. Sine 60 is root 3 by 2 minus sine 30 is half. The whole thing divided by 1 plus 1 is 2. mm gets cancelled. So this will just become g by 2 into root 3 minus 1 is the value of the acceleration. Now observe, guys. One of the mass M is going this way, accelerating like this. Another mass M is accelerating this way. Can you tell me what is the angle between these two masses? Can you quickly think and tell me what is the angle between these two masses acceleration's direction? This is 30, this is 60, obviously this is 90. This goes here, this goes like this, perpendicular. So they are already perpendicular to each other. Can you not see that? They are perpendicular to each other. That's the beauty of the problem. Now, the final concept. What is the acceleration of the center of mass? Vector form, it is m1 a bar plus m2 a bar upon m1 plus m2. Actually, these masses are also equal. If you look at it, masses are also equal. So, you know what? It is actually equal to a bar plus a bar, which is basically 2a bar divided by, what is it? Oh, wait a minute. Sorry. Accelerations are equal in magnitude but not in direction. So it will be wrong to say that I will put a bar and a bar. That's wrong. So it will be m a1 bar plus m a2 bar upon m plus m. M will cancel. So it will be a1 bar plus a2 bar divided by 2 is acceleration of center of mass. Now this is the vector form. So magnitude wise, how much will it be? Magnitude wise, how much will it be? Think about it. A1 and A2 are two perpendicular vectors. Their resultant, A1 and A2's resultant will be root 2 times of A, right? Root 2 times of A. Everybody remembers this standard thing. Two vectors are equal and perpendicular. The resultant will be root 2 times any one vector. As simple as that. So this will become A by root 2. So just substitute the value of A, which is G by 2 root 2, and then you have root 3 minus 1. Now substitute everything and you will get the answer. Substitute everything and you will get the answer. I think you should get the answer as 1.3. Okay, just substitute. Okay, that part you do it on your own. Is that okay, boys and girls? Everyone? Done. Shall we move ahead? Did you understand the concept here? This is the main crux of the problem. What I have done over here. This was A. This is also A. This will be root 2A. That is what I have done because they both are perpendicular to each other. Yep. Very good. G by 4 is it? Oh, thank you so much, bacha. Thank you so much. This should be G by 4. Yes, it should be. This is G by 4 and so is G by 4 over here. Yep. This was 2 and this 2 also came. That 2 also came. So 2 2s are 4. Yes. Thank you, Archani. Very good. You guys are observant. On which channel mathematics is crash course? No, Akash. There is no mathematics crash course going on anywhere right now. At least in English. Okay. Right now, unfortunately, I don't have a maths teacher. Okay. So that's why I'm taking care of your maths test, maths mock test on this channel because I don't want you to lose out at least on the mock test part. But if you want maths crash course, then there is a paid crash course which is there. You can just check it out. The link is there in the description. Next question. Two spheres each of mass m, each moving with speed u in the direction 60 degrees and 60 degrees north of east, south of east, okay, collide, stick to each other, common velocity will be in which direction? Let's draw the diagram. Two spheres of mass m moving with velocity u in the direction 60 degrees south of east. The direction 60 degrees south of east. So this is 60 degree, that is east. This is south of east. This is mass m, u. Another mass is moving north of east. This is north of east, again making 60 degrees, speed u, mass m. After colliding, what happens? They become a combined mass. Now, if you notice, guys, clearly, each of these masses has two components of velocities. One component is in the vertical direction. The other component is in the horizontal direction. You guys only think and tell me which of these two components will cancel each other and which components will add. Obviously, this component is opposite this component. The component of this momentum and component of this momentum, they will cancel each other. So in the y direction, they will basically cancel. So y momentum y momentum cancels each other. So what remains is only the x momentum. So 2m mass has no other option but to move in this direction. So if you conserve x momentum, what is the momentum of this mass? It is mu cos 60. What is the momentum of the other mass? It is mu cos 60. Will be 2m into v, m cancels. U cos 60 plus u cos 60 is 2u cos 60. Cos 60 is half, is equal to 2v. 2 cancels, so v will be equal to u by 2. So v will be equal to u by 2 in the east direction. Exactly. So in the east direction, that will be the final answer. Very good. Harshini, maybe another more 40 minutes or so. Okay, yes, sign components will cancel. Perfecto, perfecto. Moving on to the next question coming up on your screen. Beautiful question this is. If a ball falls vertically onto a floor with momentum p and then bounces repeatedly, the coefficient of restitution is E. The total momentum imparted is. Interesting. Look at this. If the ball falls with momentum p, after collision, the momentum will become PE, P times of E, because every time it collides, the new speed will be coefficient of restitution times the old speed. So the old momentum into coefficient will give me the new momentum. Now again, that same momentum will come down, and next time the new momentum will be PE into E, means P square. The same thing goes up, comes down, P square. Again after collision, it will become P square into E. That means PE cube. And so on and so forth. This will go on till infinity. Slowly, the height is going to reduce. P square, P cube, P raised to 4, P raised to 5. So that's how it's going to go. Now, if that's the case, in the first collision, okay, in the first collision, so this is first collision, this is next collision, this is third collision, so on and so forth. In this case, what is the change in the momentum? Because question is, what is the momentum imparted? That means, what is the impulse imparted? That's the understanding of the question. The first case, the impulse imparted or the change in momentum imparted is final minus initial. So P minus P, basically it is P common 1 plus E. See if this makes sense. In the second case, if you ask what is the change in momentum, it will be nothing but PE square minus of P. So basically it will become PE 1 plus E again. So you can see P into 1 plus E, P into 1 plus E. Alright, I think I'll just write it properly over here. This is minus P, yep. Similarly over here, if you ask what is the change in momentum, it will be final momentum minus initial momentum, which is P square. So again it will become P square common 1 plus E. I hope you understand why that minus is coming twice. Now these are the impulse imparted in each collision. So the question is, what is the total? So what is the total impulse imparted? It will be P into 1 plus E. You can see that is common everywhere. First time you have 1, second time you have E, third time you have E square, so on and so forth till infinity. It's a GP series, so you know what to do. So P into 1 plus E. So the GP series summation till infinity formula is first term upon 1 minus the common ratio, which is in this case E. So it will be P into 1 plus E upon 1 minus E. That is the answer. What a beautiful question. Let's check. Yep, option D, of course. Did you love this question? Did you love this question? Okay, it's a very, very interesting question, bacha log. Okay, a lot of students do not know what to do in this question. They just add P plus P plus P square. No, every collision the momentum changes. Momentum changes. Momentum changes. The change in momentum you calculate for each collision. You see they follow a trend. The moment you identify the trend, you know you have to use series and progression. Moving on. I'll make a video on that, Neeraj, okay, very soon. Two spheres, each of mass 1 kg, are attached to the ends of the rod of mass 1 kg and length 1 meter. The moment of inertia of the system about an axis passing through the center of gravity and perpendicular to the rod is how much? Okay, let's have a look. So the masses are here, 1 kg, and the rod is length 1 meter, axis is this one. So this is basically 0.5 meter, this is also 0.5 meter. So the total moment of inertia will be moment of inertia of the rod plus moment of inertia of the mass, but there are two such masses, so into 2. Moment of inertia of the rod is half mass of the rod. How much is it? Mass is also 1 kg into length is 1 meter, so L square by 12. Oh, why did I put half? My bad, sorry, not needed. ml square by 12, that's it. So mass is 1, length is 1, square by 12, that's it. Plus mass of each thing is 1, distance is 0.5, so 0.5 square, but there are two things, so into 2. Just do it and see what is the final answer. See if you get the answer as 7 by 2. Just check it out quickly and let me know if you are getting the answer as 7 by 2. My bad, not 12 by 7, 7 by 2. See if you're getting it. I made a mistake and you got the answer as B. Happens. Come on guys, figure it out. See if you're getting it. Ashok, tell me bacha, EMSAT also has the same theory, na Ashok? EMSAT also has the same theory, yes or no? So, can you not watch the JEE crash course lectures for EMSAT? You only think and tell me. Yes, you can watch the same classes, definitely. But Ashok, you know what? I know EMSAT also has special requirements. Like they will have slightly different difficulty, different number of questions, specific topics are differently asked. So for that, I will conduct mock test for you exclusively. Okay? That's something which I'm going to do. Akash, much better. I would say 95% okay. Thank God I took rest, or else I would not be able to conduct classes for the next 2-3 days. Missing one class is better than missing 1 week, is what I feel. Okay. If the mass of Earth and radius suddenly becomes 3 times more and half times the present value, then what is the length of the day, guys? Can you guys quickly tell me what concept is it based on? What concept is it based on? Think, mass of the Earth, the radius of the Earth changes. Which concept do you think it is based on? I think it is based on the concept of conservation of angular momentum. Yes or no? Very good. The Earth is spinning, the mass changed, something happened, somebody just ate off the mass. Yeah, whatever. Yeah. So conserve angular momentum. Angular momentum is I omega. Achha. Now, basically, if I say 2 by 5 m r square into omega. Oh, omega I can write it as 2 pi by t. Right? That's the formula for omega. Is equal to 2 by 5 new mass. Mass becomes 3 times. 3m into radius becomes half. Radius becomes half. So r by 2 whole square into 2 pi by new t. The new time period. This was the old time period. I can just call it as t naught. So a lot of things get cancelled. 2, 5, m, r, 2 pi. So many things just got cancelled. So over here I'm just left with, if I'm not wrong, just 1 by t naught is equal to 3 by, what is this, 4 into 1 by t new. So t new will be 3/4 of t naught. So 3/4 of t naught is 24 hours. 4 goes with 24 6 times. 6 3s are 18 hours. So 18 hours is the answer. Very good. Let's see if you guys have got D for IIT Delhi. You know, recently I got to know that one of my immediate senior, like 1 year senior, he has now become a professor in IIT Delhi. And I was so happy. I said a hi message to him, and he was also very happy that I'm teaching students who are getting into IIT. So, you know, it's like a continuous stream. Like students come to me, I prepare them for IIT, then they go to IIT, and then they go to my, friend, my senior from my college who is teaching them in IIT Delhi. It's crazy. He's also having fun teaching. I'm also having fun teaching. And that's how it is. So handing over kids from one place to the other. It's the beauty of life. Yep. So I'll see if I can conduct some kind of an interview. I'll just get him on the channel or something one day, and it will be fun. He's a very cool guy. I mean, you will enjoy. He's a very amazing professor. A wheel rotating at an angular speed of 40 radians per second is brought to rest by a constant torque in 5 seconds. If the moment of inertia is 0.3, then the work done in the first 3 seconds is how much? Yes, so let's try to do this particular question, okay? First of all, angular speed is given, constant torque, rest in 5 seconds. So, initial angular speed 40, final angular speed 0, time 5 seconds. From this, I can find alpha, which is final minus initial upon time. So, it is 0 minus 40 divided by 5. So, it is minus 8 radian per second square. Minus because obviously, it is retarding, no? So, minus 8 radians per second square is the deceleration. From this, I think I can find the torque, na? Torque is I alpha. Torque is I alpha. What is I? 0.3. What is alpha? 8. Magnitude wise, okay? I'm just concentrating on the magnitude. So torque will be 0.3 into 8. 8 3 are 24. So 2.4 Newton meter is the torque. Okay. Why did I find torque? I think I can find work using torque. How? Okay, I have an idea. In the first 3 seconds, no. So angular velocity at the end of 3 seconds will be initial angular speed plus alpha into t. Initial angular speed 40, alpha minus 8, time 3. 8 3s are 24, so this will become 40 minus 24, that's 16. Is that okay, bacha log? That is 16. Now what do I do? Why did I find omega? Acha. I don't even have to find omega actually, let me tell you. I can find directly delta theta. Because, I'll tell you what, work done is torque into angular displacement. Torque is nothing but 2.4. Angular displacement is ut plus half at square. Ut plus half at square. So use this 40 into t minus half into alpha is 8 into t square. Just do it, you will get the answer. Just do it and you'll get the answer. I think it should come out to be option A if I'm not wrong. Yes, it is A. So it comes out to be 201.6 joules. Great if you got this answer. You understand why I found angular displacement? Because work is force into displacement. So in rotation it is torque into angular displacement. Angular displacement is ut plus half at square. Initial speed known, time 3 seconds, minus because it is retarding. Alpha is the angular acceleration into time square. As simple as that. Okay. Moving on to the next question coming up on your screen. Get ready. What did you use, sir? Harshini? I used a kinematic equation, bacha. I used kinematic equation in case you did not understand. Omega initial into t plus half alpha t square. So I found it delta theta. It was easier. So this was the work done. This is not omega. This is basically the work. This is the work. Okay. No, not all of them are PYQs. Some are very close to PYQs. Exclusive PYQs are coming after a bit. There are, just give me a few more minutes. You are going to see exclusive PYQs after some time. Ring and disc of same mass roll without slipping on a horizontal surface. Kinetic energy of the ring is 6. What is of the disc? Okay. In general, kinetic energy of a rolling body is given by half mv square plus half rotational energy, which is half mv square plus half factor which comes in the formula of moment of inertia. Like for disc it is half, for solid sphere it is 2 by 5, for ring it is 1. So factor into mr square. Omega is v by r, so v square by r square. R square cancels. Half and mv square is common. 1 plus the factor. That means the kinetic energy of the disc upon kinetic energy of the ring will be 1 plus the factor which comes in the disc. M is same, speed is same. Ring and the disc of same mass, okay, and moving with the same speed. So mv square is same. So 1 plus the factor in the disc plus 1 plus the factor in the ring. So in the disc the factor is, it is just 1 by 2. For the ring it is just 1. That's it. Remember the formula for disk, half mr square. For ring, 1 mr square. That's it. That's the number factor. This will be 3 by 2. This will be 2. So this will be 3 by 4. Kinetic energy of the disk not known. Kinetic energy of the ring known, 6. So kinetic energy of the disk will be 6 into 3 by 4. This goes with this. This will be 2. This will be 3. 9 by 2, which is basically 4.5 joules. 4.5 joules is option C. Exam was OP. Very good. Very good. Yes, Krishna. Yes, Harish. That's the answer. 4.5 joules. Perfecto. Moving on to the next question. From a complete ring, you take out 30 degrees. The moment of inertia of the remaining part will be how much? Very easy peasy lemon squeezy question. Think about it. So you have a complete ring. Just imagine. From that you take out 30 degrees. You take out 30 degrees. So again the same axis is there. What is the new moment of inertia? Okay, you take 30 degrees out of that. See, I'll tell you one simple thing. If you take a ring, all the masses are equidistant. So when you find moment of inertia, it was summation mi ri square. R was same. So basically it was r square into sigma m. So that's why it comes out to be mr square. R was same for everything. So basically it just comes out to be mr square. This m is the mass of the complete ring. Now look at this, where a part of the ring is missing. Still all the masses are at the same distance r. So when I use I is equal to sigma mi ri square, r is same, so r square can be taken out, sigma mi. So it will become still r square into mass of whatever is left, whatever is there over here. So now think logically. This entire circle subtends angle 360. So for 360 degrees, the mass is m. For 30 degrees, the mass will be m by 12, na? Because 30 degrees is 1/12 of 360. So for the remaining 330 degrees, how much mass will be there? 11 by 12 of m. This 11 by 12 m is the mass which is left, the remaining mass for 330 degrees. So hence the moment of inertia will be 11 by 12 m into r square. If you have solved it for 60 degrees also, the answer will be very similar, just that instead of m by 12 it will become m by 6. That's all, and rest of the things will change accordingly. So these kind of questions are also again common. So this formula is the same, but this mass will now be the remaining mass. The remaining mass only is different. That you can do it logically, unitary method. For 360 it is m, for 30 it is how much, for 330 it is how much. Yeah, the level feels so hard, but actually it is very easy. Next, a disk rotates freely with energy E. A ring having same radius, double the mass, is gently placed. This kind of questions, like I told you, is based on the conservation principle of angular momentum. So a disk is rotating. This is your disk. This disk is rotating with some angular speed. Imagine a ring having the same radius but double the mass. Okay, so mass of the disk is m. Now you take a ring. It is not moving. You place it. So now it becomes one combined system. You have the disk also and you have the ring also. So they both of them move together with a new angular speed. Question is, what is the new energy? So I feel I'll find this. From that I can easily find the new energy. It is not that difficult. So conserve what? Angular momentum. Conserve the angular momentum. Initial angular momentum for the disk will be m r square by 2 into omega. Remember the ring has a mass of 2m, don't forget that. Plus 0, because the ring is not yet rotating, is final moment of inertia which will be mr square by 2 plus ring has a moment of inertia of 2mr square, no by 2 over there, mass is different, into new angular speed. mr square cancels. This will be omega by 2 is equal to half plus 2 will be 2.5 or 5 by 2, and this will be omega 1, 2 cancels. So omega 1 will be omega by 5. Once I find the new speed, I can find the new energy. How? Observe. The new energy will be how much? Okay, so final by initial will be half total moment of inertia, which is mr square by 2 plus 2mr square into omega 1 whole square upon initial kinetic energy will be half I is just mr square into omega square. Final energy I don't know. Initial energy is given, it is E. It is just basically E. Half cancels. Half plus 2 is 2.5, so 2 by 5 mr square, and omega 1 is omega by 5, so omega by 5 whole square, whole thing divided by half mr square. Now do the math, guys, you're going to get it. So K final by E will be mr square cancels, this 2 goes on the top, becomes 4, this 5 comes below, this will be omega square. Oh, sorry, this omega square was also there. That will also cancel, by the way. That will also cancel. No need of that. Just this 5 square will be there, which is basically 25. Just check this out. Oh, what did I just do? I just wrote it as 2 by 5. My bad. This was 5 by 2. So sorry, guys. I'll just write it again. Half plus 2 is 2.5, so that is 5 by 2. 5 by 2 into mr square, that should be correct, and this will be 5 and by 2, this goes on the top, and this will be 1 by 25. Now check if final kinetic energy 2 cancels, 1 by 5 will be remaining, is E by 5. Check if it is E by 5. Yes, it is E by 5. Correct. Denominator here. mr square by 2 in denominator, no. Final by initial, bacha. So initially there was only disk which was rotating. So the disk had a moment of inertia of mr square. That's it. Yeah. By 2. Yes. There was 1, 2 over here also. Thank you. Yep. There is 1, 2 over there also. Yep. Definitely. Just check it out. Yes. The answer should come out to be E by 5. Yep. Okay, is that okay, bacha? Haris? Fair enough. Moving on to the next one coming up on your screen. Yep, great. Chalo. A wheel has moment of inertia rotated by 60 watts, 10 seconds. Number of rotations made by the wheel afterwards in 1 minute is how much? That is the question. Let's try to understand. Power is given, moment of inertia is given, how much time the power is applied, that is also given. So it was at rest. You give it 60 watts for 10 seconds. It will have some angular speed. After that, you wait for 1 minute. The angular speed is same. It's not changing. Constant speed. So the question is, how many rotations does it make in this period? I feel I should find this omega. If I know what is the angular speed, I can find how many times it rotates in 1 minute. Okay, so let's try to do that. So for that, let's solve this particular part, the initial part where it is accelerated. So the power is given for 10 seconds. That means the work done goes into kinetic energy. Work is power into time. So power multiplied by the time is kinetic energy, which is half I omega square. Power is how much? 60 watts. Time is nothing but 10 seconds is half moment of inertia 3 by pi square into omega square. So basically This will become 62 is a 120. 120 divided by 3, that's 40. Just check this out. Yep. So this will become 40. Yes, 62 is a 120, 40, and there will be 400 over here and pi square over here, which will be omega square. So omega will be basically 20 pi. See, if omega is 20 pi radians per second, once I get it is 20 pi radians per second, each revolution is 2 pi radians. So 20 pi radians per second is basically 10 revolutions per second. Is basically 10 revolutions per second. Perfect. So now we can find out how many revolutions does it undergo in 1 minute. So in 1 minute, it will be 10 revolutions are there per second. So into 60 seconds. So that will be 600 revolutions. That is the answer. Exactly. There you go. Where is it? Option D, of course. That's the answer. Got it? Understood? So I have used work kinetic energy theorem. Work done is power into time, because power is work by time. And kinetic energy is half I omega square. Substitute, I got omega. That omega is maintained afterwards for 1 minute. So constant speed. So I know the speed, I know how many revolutions it undergoes. Next question coming up on your screen. A wheel, weight, height 20 centimeters, force is applied. What is the minimum value of F? Okay, let's understand. See, this wheel is there over here. Okay, imagine that you have to make it climb up. The wheel is having some weight, it has to be dragged over a step of height 20 centimeters. Great. And the force is applied over here. Okay, so what it means is that here, okay, just imagine this. You can see that there is a force which is applied. This is more like a step kind of a thing. Okay, this is more like a step kind of a thing. And you want to pull it over this pivot point or this step's edge so that it is able to climb on that. Now see who is helping and who is against it. This force is trying to pull it up, but the weight is trying to pull it down. The weight is trying to pull it down. This is your step. This diagram is not so clear, so I'm making a very clear diagram. So I hope you now understand. Force is giving a positive torque, mg is giving a negative torque against the climbing up motion over the step. So if you want to just take it up, the torque of the force should be balanced by the torque of the mg. Now for that, I need to know how far is that force from that step. I need to know how much is this distance. I also need to know how much is this distance. If I know this distance and if I know this distance, I know the torque and I can solve the problem. Now in order to find that out, here is what I'm going to do. Remember, it's given, the radius of the wheel is given and the step's height over 20 centimeters, you have to bring it up. So basically you can think this height is 20 centimeters and you can think the radius is 40 centimeters and this base is nothing but root of 40 square minus 20 square, which is 20 root 3 centimeters. Now this 20 root 3 is exactly this value, 20 root 3, that's the base which comes over here. This height is exactly this value, so that is basically 20 centimeters. Now you can solve the problem. So the torque by that force should be just balanced by the torque of that weight, R of the force, R cross F, so that R is basically 20, force I don't know. Torque of mg will be this 20 root 3 into the weight itself, that means mg. 20 will cancel, so it will be root 3 times the mg. Mass is given, how much is it? 20 kg. So 20 root 3 kg weight, because options are in kg weight. That's it, that's the answer. Where is it? 20 root 3. Venetians, I would say check out my playlist of rotation, nurture playlist. If you have still time, okay, before the exam, if you want to understand rotation properly, I have conducted some 6-7 classes at least on that. step by step. One lecture just on moment of inertia, one lecture on torque, one lecture on angular momentum, one lecture on conservation, one lecture on rotation and translation and rotation combined. So I have conducted. So if you want to sit properly and understand the classes, through the classes, okay? That will be the best way. If you see one shots, you will get upar se some slight value or slight understanding you will get, but you will not get a good understanding of what rotation is. Thank you, Kavish, so much. Okay, what about this question? O is the center of an equilateral triangle. F1, F2, F3 are the forces. What should be the magnitude of F3 so that the total torque about O is 0? Achha, I think this is easy. What you can do is, this is an equilateral triangle. So this force will give a torque. This force will give a torque. So torque by force 1, torque by force 2, both will be anti-clockwise. That should be balanced by this force will give clockwise torque. So torque by force F3. Each force is at the same distance from the center because it's an equilateral triangle. Be it this force or this force, I know this point looks little offset, but the distances are same. So basically this is D into F1 plus D into F2 is nothing but D into F3. DD cancels, so F3 will be F1 plus F2. That's the answer. See if this is making sense. F1 plus F2. So that's the answer, guys. As simple as that. These values are not necessary. It is chumma given, not at all useful. Just to confuse you. The net torque is 0. So all the torques by individual forces should cancel out each other. All the distances are same because it's an equilateral triangle. That's all. That's the concept being used over here. Next question coming up on your screen. Try to answer this. A disc is at the top of a rotating plane. The question is basically, to find out, in order to complete the loop at the bottom, what is the minimum height of the inclined plane required? Okay, try to understand, visualize, and then we'll start solving. Come on, guys, if you are new to the channel, make sure you hit the subscribe button. And if you are already subscribed and you have hit the subscribe button, you know what to do. Go ahead, smash the like button right away, right now. Sure. Hasta la vista, Khushi. Take care, bacha. Take care. So, over here, you leave a disc from here. It rolls down, acquires certain velocity. After this, it is completing a loop of radius r. Question is, what should be that height? Okay, I know what to do. At the bottommost point, it should have minimum speed of root 5 gr for it to complete the loop. That's a standard thing. How will it get this speed or kinetic energy? It has got kinetic energy because of the potential energy over here. So use energy conservation. Potential energy gets converted into kinetic energy. Potential energy is mgh. Kinetic energy is half mv square plus half I omega square. Both energies are there. So half m v square plus half moment of inertia of a disk is mr square by 2 into omega. Omega is v square by r square. So this will become mv square by 2. This r square cancels. 1 plus 1 by 2, which is basically 3 by 2 mv square is equal to mgh. mm cancels. V is root 5 gr. So gh is equal to 3 by 2. Roots square will cancel that root out. So I'll just have 5 gr over here. Okay, I'll just use this over here. That's all. So 3 5s are 15. Gg also cancels. So h will be 15r by 2. That is the answer. 15r by 2. Oh, I think there was... Oh, my bad, guys. I think I missed one 2 over here. There was one more 2 over here. 1 plus 2 is 3 by 2. This one more 2 was there. So this was basically 4. My bad. This was 4. So I'll just write it once more. Yeah. This was basically 4, 4, and 4. Yeah. 15. Yeah. I left the 2 in the bracket. Yes. Thank you. So option is 15r by 4. That's it. Great. Yes, Kavish, I know. A lot of students are benefiting from it, and many students are, thinking what do we do? Should we just, many students are seeing full detailed classes right now. 3 weeks before, who sees full detailed classes of all the chapters? I mean, you should not do that. Only for certain topics you can do that. This is a time where you should be practicing a lot of problems. You should be just looking at only certain sub topics which you do not know and all of that. Just 3 weeks before. Okay? Yes, very good, Haris. That's the best way of doing it. Please only solve problems as much as possible. Just devote maximum 1-2 hours in a day of studies of 12 hours for theory. That is maximum, I am saying. Other than that, you have to just solve problems, bacha log. NEET also rotation has high weightage. No, not very high weightage, decent weightage. Not low, not high, medium weightage. Moving on, next question. Let's try to solve this. A boy and a man carry uniform rod of length L such a way that the boy gets 1/3 load, the boy is on one side, the distance of the man from the other side. Okay, let's visualize. This is a rod, length is L, boy is supporting from one side. So how much load is he bearing? mg/3 or 1/3. So mg/3 from the boy's side. The other person is somewhere here. I don't know where he is. Let's assume that this is basically x. I know the weight of the rod will be exactly at the center, mg/2. This is exactly the center of mass. Okay. So obviously, this is not mg/2. My bad. It is at L/2. The total weight will be mg. My bad. Okay. So the total weight of the rod will be exactly at L/2. That will be mg. Now, out of the total weight, 1/3 is being handled by the boy. So the remaining weight will be handled by the man. So that will be 2/3 of mg. So 1/3 is gone. So 2/3 will be handled by the man. Now this entire thing is in equilibrium. So balance the torque. That's all. So the net torque will be 0 because everything is balanced. So at which point you want to take the torque? Take the torque about this point. So this force will not give any torque. Mg will give clockwise torque. So this distance is basically L/2, I suppose. So L/2 into mg clockwise. This torque will be negative. So minus what is this entire distance? Think about it. L minus x. So L minus x into 2/3 mg will be 0. Now just solve this and see what you get as the answer. So L/2 mg minus, okay, here you have L into 2/3 mg minus plus, so x into 2 mg/3 is equal to 0. So solve this and see what is used that your answer is going to be. Is it L/6, L/5, L/4 or L/3? Solve it, guys, and see if you get it as L/4. See if you get it as L/4. Okay, let's try this out. Can we take torque at the center of the rod for calculation? Definitely, Dhanga. You can do that. Definitely. No harm. Take the torque at the center. So this will be L/2 into mg/3 will be balanced by this distance, L/2 minus x into 2/3 mg. So that also will give you the answer. Definitely you can do that. Okay. Either ways you'll get the answer. Oh, we have come to now PYQs. Ready, guys? PYQs now. Okay. Exclusive PYQs which are handpicked. Okay. So coming up on your screen, start answering the questions. This one, what does it say? 2 blocks are there, connected by a spring, placed on a smooth surface. Impulse is given to the heavier one. What is the velocity of the center of mass? Okay, let's draw the diagram. So one block heavier is 10 kg, connected by a spring to a lighter block 4 kg, smooth table. This heavier mass is given a speed of 14 meters per second. If you give impulse to this guy, what will happen to the other guy? If you suddenly hit the heavier block, this immediately acquires 14. Do you think immediately this guy will start moving? No, right? It will take some time because the spring acts like a shock absorber. Absorbs the shock. It will start compressing, yes, of course, but it will take some time to compress and then begin the motion slowly and then accelerate and acquire velocity. So it will take some time. At that instant, it will have 0 velocity. That's it. So finding the velocity of center of mass has never been easier. m1 v1 plus m2 v2 upon m1 plus m2, guys. m1 is 10, v1 is 14 plus m2 is 4, velocity is 0 upon m1 plus m2. So this will be 10 into 14 by 14, which is basically 10. So answer is 10 meters per second. Exactly, Subhadra. Yes, option C. Very good. Understood? Can we move ahead to the next one coming up on your screen? Here it is. A ball of mass 200 grams is on a vertical post, height 20 meters. A bullet hits it. Then after the collision, they move independently. The ball falls at 30 meters. The bullet falls at 120 meters from the foot. What is the value of the initial speed of the bullet? Okay, interesting. Let's try to draw the diagram first. This is a vertical post. I'll show before and after diagrams. Okay, this height is how much? 20 meters. Okay, so there is a ball of mass 200 grams. 200 grams. Okay, it is at rest. After a bullet, so this bullet is going to hit it with certain speed. The mass of the bullet is 10 grams. Obviously, this mass will acquire some speed. This bullet will also acquire some speed. The bullet hits the ground at a distance of 120 meters. So the bullet will acquire a good speed, let's say u1, and it hits the ground at 120 meters. The ball which is there, it hits the ground at 30 meters. It acquires a different speed. Let's say u2, it hits the ground over here at 30 meters. That is the question. Did you understand the question? Are you able to visualize? That's why I always show diagrams. You will get an understanding and then you will understand what to do. That analysis is very important. Now over here, I feel you should use momentum conservation, obviously. So conserving momentum, conserve momentum, initial momentum 10 grams, okay, 10 grams into u plus 0 is equal to 10 grams into u1 plus 200 grams into u2. Okay, that's what it is. So I think at max I can just cancel 1 0 from every place. That's it. So u will be equal to u1 plus 20 u2. Now it's just a matter of substituting. How do I find u1 and u2, you might ask? Guys, I know the range formula in general for a projectile. If you know that, that is going to make your job easy. Range is horizontal speed into root of 2h by g. Into root of 2h by g. This root of 2h by g will be root of 2 into height is 20 by 10. 0, 0 cancels. So basically root of 4, which is 2 seconds. So root of 2h by g is basically 2. From this, I can find u1 and u2 separately. How? Observe. u1 is 120. So 120 is equal to u1 into time. So u1 will be basically 60. So I'll just put u1 as 60 over here. Plus 20 multiplied by, for u2, range is 30, is u2 into time. So u2 will be just basically 15. So just put 15 over here. I think my job is done. Just check it out. What is the final answer? 30, so this will be 360. Check it out. If the answer is 360. Yes, it is. Beautiful question. Use the concept of projectile from a height. So many students will be like, sir, can I skip projectile from a height? Is this question solvable without projectile from a height concept? Definitely not. Mixed concept question has come. Thermo I will not be doing, Abhishek. Please watch my older lectures from Zero to Hero or Flash or Nurture. Okay, fine. I think I explained before why I'm not going to do that, because I was ill and I don't want to miss SHM and waves also. Work power energy, RBD, decent weightage. I would say work power energy comes in many chapters, so you cannot isolate it separately. Work power energy is very important. Rigid body mechanics, expect at least 1 to 2 questions. Okay. Krishna, you have to get into the habit slowly. Read line by line, break the question into parts. Do not look at the solution. Try to make diagrams without looking at the solution. Slowly you'll get a hang of it. Okay? Tarun, because I'm already busy now, bacha, so that's the reason. So I cannot do justice. If I come everywhere, then I will be giving in my half effort. So I don't want to do that. If I do something, I do it properly, you know that. Or else I'll not do it only. Okay? No point doing it with half the energy. Okay? So that's the thing. So there are blocks placed on the same straight line with coordinates this and this. The blocks of 10 kg is moved on the same line through a distance of 6 towards the other block. The distance through which the block of 30 kg must be moved to keep the position of the center of mass unchanged. Okay, standard type of question. Center of mass is somewhere here. This is 10 kg. This is 30 kg. If you move 10 kg by 6 centimeters towards the other block, then you will have to obviously move this mass by some distance to keep the center of mass unchanged. And whenever center of mass is at rest, I have given you one formula. If the center of mass is at rest, then the formula is m1 delta x1 is or plus m2 delta x2 is equal to 0. So here magnitude wise it is m2 delta x2. Only two masses are there, so magnitude wise I can just use this formula. So mass 1 10, delta x 6, mass 2 30, delta x I don't know for the other guy. So this is going to be nothing but 60 divided by 30, which is basically 2 centimeters. So move it by 2 centimeters towards the 10 kg block. Yes, towards the 10 kg block. No, it's not away, guys. I think by mistake the away option is marked. So it is towards the 2 kg block, not away. I will correct that option. Yep, don't worry. Moving on to the next question coming up on your screen. Solid cylinder, solid sphere, same mass, radius, rolls down. They start from rest. The speed of the solid cylinder to that of the solid sphere in which they reach the ground. When they reach the ground will be how much? That's the question. Interesting. So when you leave any object and it comes down, obviously it accelerates and it acquires some velocity. In order to find that velocity, I can use this equation. V square is u square plus 2 into acceleration into displacement. Now the acceleration also has a standard formula. If you remember, it is g sine theta upon 1 plus the factor which comes. Yes. Now g is same, theta is same, s is same, 2 is a constant. So can you not see v is directly proportional to 1 by root of 1 plus that factor which comes. So therefore the velocity of solid cylinder to solid sphere, cylinder to velocity of sphere will be root of 1 plus the factor in the cylinder, 1 plus the factor in the sphere. That's all. So what is this factor which comes in the formula of moment of inertia? 2 by 5 mr square. So factor is 2 by 5. 1 plus solid cylinder. Solid cylinder, the factor is mr square by 2. So half is the factor. So that's it. So this will become root of 1 plus 2 by 5 is 7 by 5. This will be 3 by 2. So this will become 7 2s are 14. 5 3s are 15. Yep. 14 by 15. Root. That is the answer. Hello, Sanatana Marie. Yep. Is that clear, bacha log? What a beautiful question. This concept of acceleration is used and kinematic equation is also used. Rest other things are simple. Do not try to remember the formula in any other way. It will look very confusing and difficult. So we have come to the final part of the session where I tell you guys, I'm going to give you daily practice problems. I made a promise to all of you. I'm keeping up to that promise. You have to sit and solve these problems. Answers are there, solutions are also there. Okay, I'll be pasting the solutions also in a bit and I'll be sharing the PDF to all of you in some time on the Telegram channel. Link is there in the description box. And remember, all the short notes of all the chapters will be available on the link which is provided in the Telegram channel. Make sure you check that out as well. I hope you guys learned a lot, solved many questions. If you are following what I'm telling you, revising through the short notes, then seeing the basic formula revision at the start of the class, then seeing the problem solving, and then looking at the PYQs also as I solve, and then solving the daily practice problems. And apart from that, whatever material you have, you can use it. If you are doing that, I am telling you 99 percentile is guaranteed. It's very easy. Okay? It's not anything out of the blue or something which is impossible. That is the mantra. As simple as that. And I'm giving you that recipe, whether you want to cook that recipe or you just want to keep the ingredients on the shelf, that's up to you. Okay? So I hope you enjoyed. Make sure you put up the comments right now after the session is over on how much you enjoyed or anything that you would like to ask. And make sure you subscribe as well as like the video. Thank you so much. This is Captain Shreyas and I'm signing off. Hasta la vista. See you again tomorrow.